So this is the start of project 4. So I'm going to give you a little background on Riemann sums. So Riemann sums pretty much are graphs on the XY axis, and you make what looks to be a bar graph. Now for the right, there's a right one and a left one. The right Riemann sum, you go from the first right value. So instead of starting at 0, you'd be starting from the first value and then going left with it. And then you'll make all of your bars. And then the difference between the right and the left is the left one will instead be coming out of the going right from that same value. So there'll be a big kind of hole right at the beginning, and then the values will start like that. So what you're pretty much doing after you've taken the left and the right is you take an average of the area under the graph of both of them, and then that'll get you a rough estimate of an answer. But if you want to have a more precise answer, you're going to take more bars so that you're taking more estimates and you're getting more data, and it'll be more precise.
So here's the data we got from dragging it across the rough surface, which was a rug. And we got 7-inch intervals, so 7, 14, 21, 28, 35, and 42. That's the distance. And over here is the force in newtons. And our points were 12, 11, 11, 12, 12, 12. So to find the area under the curve, which is going to be the total work done, because we know that work equals force times distance, then we can do left and right Riemann sums and average them together. So here's the left, or that's the right Riemann sum. There. All that space. And this would be the other Riemann sum. So, like that. There we go. And when you add up all those numbers and multiply them by 7 for the width here, then for right you get 490 joules of work, and left you get 406 joules of work. And when you average those together, you get about 448 joules of work on the rug. And here's the data for the smooth surface, which was just tile. Go 2, 4, 6, 8, 10, and 12. That's the force in newtons. And here's the distance again in 7-inch intervals. And 42. And we got 9, and then 10, 10, 10, 10, 10 across. And so we do the same thing again with the left and right Riemann sums. Just finding the area for those. The area under the curve, so There we go. And for the left Raymond sums, we got 343 joules, and rate we got 413 joules of work. So the average for the smooth surface is much less at 378 joules of work.
So, on the rug, pulling the stack of papers across took 498 joules. And on the tile up in the faculty room, it took 378 joules of work. And this can best be, the discrepancy between the numbers can best be described as by friction, because there's uneven surface levels on the rug and along with the stack of papers, so it's going to take more work because it's not a steady ground. It won't be a constant rate of pulling. While you're upstairs on the tile, there is no friction because it's all one smooth surface. You can just pull it along and it will just slide across. And that's the reason for the difference.